This video helps you with the boom card set, one, none, or infinite solutions. So in each of these situations, I can try to solve the equation and arrive at a conclusion. So when I say equation, really I have a system of two equations. I have that equation and that equation. And what this could look like when it is seen as a system is y equals x plus 2 and y equals 20. So I would have a system, two lines on a graph, and the question is, do these two lines meet at one point? Do they never meet? Or are they really the same line? That's what I'm asking when I consider one solution, no solution, or infinite solutions to a system. In this case, I can simply solve, and I get that x is 18. So there is one solution, and it is where x is 18, and obviously it would be where y is 20. Here is a new problem. I would have an equation y is 3x plus 10. Another equation, y is 4x plus 5, and by substitution, I could set those two things equal to each other. So now I need to combine some terms. What I discover here is that these are actually the same line. It's the same equation on both sides. And so two lines that are the same have infinite solutions. Any point that I could pick on either of the lines, it would also be a point on the other line, of course, because they're the same line. But what would happen if I tried to continue this equation to solve for x? If I try to find out what x is, here's what will happen. I will arrive at this statement. X equals x. If I arrive at that statement while trying to solve for x, that is an indication that this solution, it's infinite solutions, meaning the system has infinite solutions. I could put any number there and it will work. What about this system? Just by using number sense, I could ask myself, if I take a number and add 2 to that number, will that ever be the same thing as taking the same number and adding 3 to it? And just by number sense, I can understand that could not happen. So there must be no solution. If I tried to solve the equation, I might do something like this. That just makes it more clear, or clear again. There is no number that will work. There is no real number that can be the same thing as that same number plus 1. I might also try this. If I'm solving and I arrive at a statement that is not true, that is yet another indication that there is no solution. A final way that I could just check myself is to think about these two equations as linear equations graphed. Here I see that both lines have a slope of 1, and that they have different y-intercepts. So they are not the same line, they have different y-intercepts, but they do have the same slope. So they are parallel lines that by definition never intersect, and that confirms for me that there is no solution. Here, simple inspection shows me that it's really the same line. Same equation on both sides. If I try to solve for x, I get x equals x. And again, that is an indication. It's the same thing, infinite solutions. In this case, if I solve for x, I'm going to get one solution, and that solution will be 10. Let me simplify here. A glance at it, I see x plus x is 2x. The question is there any real number that can work for both of these? And you already knew no, but anyway I try to solve the equation, I'm going to arrive at an untrue statement. And that helps me to know no solution. And yet again, I see two lines with the same slope but different y-intercepts. That is a no solution.